Okay, so we're going to continue graphing these exponential functions. And so one thing I'll mention real quick is that on the homework, sometimes when graphing these, they're going to refer to using transformations. And we will talk about that a little bit more when we start to graph when we have base E. And so we'll see that in a little bit. But what you'll notice is that with the exponent, whatever you add and subtract to x is causing it to shift left and right. So you can see that you add 3 to x, it actually shifts the graph to the left 3. And when you subtract 2, it shifted us to the right 2. So I just want to mention that because when you're doing your homework, sometimes if you're using the platform My Math Lab, you have to include the shift for it to graph for you on there. Okay, and so looking at E, this one would actually be a reflection because of the negative right there. But I'm still going to make a table like I've done on the previous ones. Now, what I will point out is this is really what's taking place here is this is f of x equals -1 times 5 to the power of x. So the negative is not actually with the 5. It gets applied after the fact. Okay, because if you remember, part of the rules on this is that your base has to be greater than 0 and also your base cannot equal 1, right? So we couldn't have a negative base here. So that negative is actually after the fact. So then now we're going to make a table, and an easy value to plug in would be 0, right? And so if you let x equal 0, you're going to get -1 times 5 to the power of 0, which would just turn into -1 times 1, which is -1. So when x is 0, my y value is -1 right here. And then let's see if I plug in a 1, I'll get -1 times 5 to the power of 1, which then would just give me a -5 right there. So when x is 1, I'm at -5. And then also my horizontal asymptote, since I don't have anything being added on the back end, basically I have an understood 0 back here. I do have a horizontal asymptote going across right here at y equals 0. And so that's been the horizontal asymptote we've seen thus far. And so what's different about this graph is that it's going to be under the horizontal asymptote. And really with those 2 points, I could pretty much draw this because the asymptote's there as my guardrail. So I know that when I kind of go up to the left, I'm going to kind of go along that right there. But we can find one more point. Like if I were to plug in -1, I'd get -1 times 5 to the -1 power, which then would be -1 times 1/5, which then would be -1/5. So you can see that I'm getting closer to my asymptote there. So I'd be really close to it, about right there, -1/5. And so then from here, we'll go ahead and draw this. So we kind of come along the asymptote, our guardrail right here, and then this is going to go down real quick. So this goes down real quick like that. And that should be good. And so depending on what homework platform you're using, like I said, when you're if you're using My Math Lab, you'll have to click a button that will say, okay, this is a reflection across the x-axis so that it can graph it for you. Okay, let's see. Looking at F, um, pretty much kind of the same, except that my base is a fraction. We do have that negative out front, so once again, that gets applied after the fact. So we'll go ahead and make a table. And so let's see. Let's start with -1. So we're going to have -1 times 1/6 raised to a -1 power. And that -1 will cause me to take the reciprocal there. And so then I'm going to end up with -1 times 6, which is -6. So at -1, I'm all the way down here at -6 on my graph. Oh yeah, I keep forgetting to do this, but it's probably best to do it first, my horizontal asymptote. So my horizontal asymptote again is just going to be at y equals 0. That will change on the next problem. We'll get something a little different, but I do have y equals 0 again as my horizontal asymptote. Okay, let's find a couple more points. So let's see, let's find 0. So let's see, we're going to get negative 1 times 1/6 raised to the power of 0. Well, anything raised to 0 other than 0 is going to be a 1. So we get negative 1 times 1, which gives us negative 1. So we've got negative 1 right there when x is 0. And then if you want to find one more point, let's see, what about positive 1? So let's see, we're going to have negative 1 times 1/6 raised to the power of 1. Well, that's just going to become negative 1/6, which once again, that's just going to get me closer under that guardrail, my asymptote right there. So something like about right there. And so now we'll just kind of connect this with the smooth curve and go along my guardrail right here. And there we go. And so once again, as far as transformations, this would be a reflection. Okay, the next couple we're going to look at, where our horizontal asymptote's not going to be at 0 anymore because we have that -2 right here, and that's going to cause the graph to shift down 2 units. But once again, we'll make a little table here, but that is where my asymptote's going to be right there is at y equals -2 now. So that's a little different than what we've seen so far. So y equals -2. And we'll see why when we start to make a table here. So let's see x and y. And so we can start off with like plugging in 0. And so let's see, we'll get 3 to the power of 0 minus 2. Well, 3 to the power of 0 is going to be a 1. 1 minus 2 is -1. So it's 0, when x is 0, y is at -1 right down here. Then let's plug in a 1. 3 to the power of 1 and then minus 2. So you're going to get 3 minus 2, that equals 1. So at 1, we're at 1 up here. And if you want to keep going, you can. It's just going to start going up at a faster rate. So let's see, what about 2? So you'll get 3 to the power of 2 minus 2. So you're going to get 9 minus 2, which is 7. So at 2, we're all the way up here at 7. And if you go in the other direction, you're just going to start approaching the asymptote, and it'll get kind of messy because you're going to get fractions. And so I'll do 1 just so we can see it. So let's see, -1. So 3 to the -1 power minus 2. Well, this would become 1/3 minus 2. Well, minus 2 is the same thing as 6 over 3, right? 6 divided by 3 is the same thing as 2. I'm just doing that so I can have my common denominator. And so I end up with -5/3. -5/3, which is roughly about -1.66 repeating. And so at -1, I'm right about right here. So as you can see, I'm just going to start approaching my asymptote there as I move to the left. And so with that, I'm ready to go ahead and graph this. And so here we go. All right. Um, One thing that I've been forgetting to do is list the range because that will be something that will be asked on your homework. So let's go back and look at a couple of these here. So the range on E and F are both going to be from -infinity up to 0. And you have to use a parentheses because you approach the 0 value, but you don't actually get there. And same thing with my range over here. This is going to be from -infinity up to 0. Now looking at G though, this one got a little bit more interesting because we had a shift with my horizontal asymptote. So my range on this one is actually going to be from -2 up to positive infinity. My range. So let's see, from -2 to positive infinity. All right. And then let's see, our next one, H, we have another shift, a vertical shift. We're going to go up 3, and that's where my horizontal asymptote's going to be right. Here's where my horizontal asymptote is going to be at y equals 3. And also, if you are using MyMathLab, you have to plot your asymptote on the graph, and it needs to be a dashed line. So just be aware that that's part of the process. Okay, so we need to find a couple points, and so you kind of want to pick some friendly points. We don't want to get too crazy. Let's see. We could pick, zero's always good, but we need to pick some stuff around there too. So a lot of times folks will just say, -1, 0, and +1. And that's what we can kind of start with and see what we get from here. So if I plug in -1, I'm going to get 1/2 raised to -1 plus 3. And that -1 causes this to reciprocate into 2 plus 3, which equals 5. So when x is -1, y is 5 right there. And then let's see, what about 0? Well, we get 1/2 to the power of 0 plus 3. Well, that would become 1 plus 3, which equals 4. So 0, I'm right here at 4. Okay. And then if I plug in a +1, um, then let's see, I'm going to get 1/2 plus 3, which is, well, 3.5 right there. So I'm getting closer to my asymptote right there. And really, that's fine. That's enough points. But if we want to get a little extra practice, I'm going to go ahead and plug in -2, just so I can get another one kind of going up right here. And so let's see. So we're going to have 1/2 to the power of -2, and then plus 3. And so you have to take the reciprocal here, and then that becomes a positive exponent. And so then 2 squared is 4. 4 plus 3 is 7. So let's see, we've got another point right here at 7 right there. So when x is -2, y would be 7. And that seems good. That's plenty of points to go ahead and get a nice smooth curve on this one. So we just kind of come down like this, go along the guardrail, and there we go. And then my range this time, it's always going to have something to do with the asymptote, right? Either from the asymptote to positive infinity or from negative infinity to that asymptote value. This time we're above the asymptote, so my range is going to be from 3 up to infinity. 3 up to infinity. Okay. As we continue on, we're going to have more and more things kind of going on here. So technically we have 2 transformations here. We're going to shift to the left 2 and down 4. But once again, I'm going to kind of make a table for this. But uh, I will go ahead and put my asymptote down here at -4. So at y equals -4, there's my horizontal asymptote. And so then once again, this is gonna be kind of interesting because I wanna pick values in my table that if I plug in 1, that might not be a good one, because if I plug in 1, I'm gonna get 3 to the power of 3, which is 27, which would be way off my graph. And so I talked about this in a previous video. You kind of want the numerator, I'm sorry, your exponent, you'd like it to be a 0, a 1, even -1 would be fine. Those are typically, most instructors, that's what they kind of shoot for. They want to go for your exponent being 0, 1, and like I said, -1's not a bad one. So we'll go ahead and do that. So I'm going to plug in like -3. We'll start with -3. So that would give me 3 to the power of -1 minus 4. And so 3 to the power of -1 would be 1/3 minus 4. Well, 4 is the same thing as 12 over 3, right? 12 over 3 is the same thing as a 4. And so I get that common denominator. So I get a -11 over 3, which is close to -12, but not quite. It's, I'm, what did I say? Yeah, close to -4, -3.66. So let's see. So at negative 1, 2, 3, negative 3.66. So you're about down right there. So when x is negative 3, my y value is getting close to negative 4, but remember we approach but don't touch. Okay, the other points should be pretty easy. So if I plug in, let's say negative 2, then I'll get 3 to the power of 0 minus 4. So then I'm going to get 1 minus 4, which equals negative 3. So at negative 2, I get negative 3. And then let's see, let's plug in negative 1. If I plug in negative 1, I'll get 3 to the power of 1 minus 4. Well, 3 minus 4 is negative 1. So that's going to be right here. And honestly, that's fine. Those 3 points are good enough. And so here, the asymptotes there is your guardrail. And then we just kind of go up like so. And then last but not least, my range is going to be from negative 4 up to infinity. Okay, the next one's very similar, except that our base is going to be 1/4. And so it's going to be a decay instead of a growth one. Instead of increasing, it's going to be decreasing coming down. I am going to shift up 1 unit right here. So I'm going to have a horizontal asymptote right here at y equals 1. And so once again, we'll plug in some values. And like I said, we'll plug in values in order to make the exponent negative 1, 0, and positive 1. So to be negative 1, I need to plug in a 2, right? So 2 minus 3 is negative 1. So I'll have 1/4 to the negative 1 power, then plus 1. Well, the negative 1 causes this to reciprocate into 4 plus 1 equals 5. So when x is 2, I am going to be up here at 5. Let's see. I'm sorry, yes, when x is 2. Let's see, right there. Okay, then I'm going to plug in 3. Let's see, 3. So 3 minus 3 is 0. So I'm going to have 1/4 to the power of 0, and then plus 1. So that's going to become 1 plus 1, which is 2. So at 3, I am at 2. So like I said, it's decaying, right? It's starting to decay. It's going down. And then we can plug in 4, and that's going to get us a fraction, but that's okay. So when you plug in 4, you're going to get 1/4 to the power of 1, because 4 minus 3 is 1, and then plus 1 right there. So 1/4 plus 1 is 1.25. So we're at 1.25, getting pretty close to that asymptote right there. And so we just kind of draw this decaying and then going along the asymptote right there. And then the range on this one would be from positive 1 up to infinity. So positive 1 up to infinity. Okay, we got a couple more here, so we're going to get plenty of practice. Once again, we're going to kind of have multiple transformations taking place here. So if you look at K, you have a reflection and you're shifting up 2 units. So the plus 2 is where my horizontal asymptote is going to be located. Okay, so y equals 2. And then that negative is going to cause it to where it's going to open. The graph is going to go underneath my asymptote here. And so once again, we'll just kind of we'll pick values like we'll start with negative 1 and we'll do 0 and positive 1, and that should be good enough. So remember that negative gets applied after you have 4 to the power of negative 1, and then we have that plus 2 right there. So the 4 to the negative 1 turns that to a 1/4, and then you have the negative that was just waiting for you right there. So this becomes negative 1/4. Then that plus 2, I'm going to change that to plus 8 over 4, because that's the same thing as a 2, right? And now I have my common denominator to where I can do negative 1 plus 8 is 7 over 4, which is 1.75. So at negative 1, I'm going to be at 1.75, which is up about right there. Okay, now we got the hard one out of the way. The rest should be fairly easy. We're going to plug in 0. Now be careful that negative 1 does go on the outside. And so what happens here is 4 to the power of 0, yes, that turns to a 1, but then that times negative 1 comes in afterwards. And so you get negative 1 plus 2, which is then going to be positive 1. So at 0, we're at 1. And then now we'll plug in a 1. So we're going to have negative 1 times 4 to the power of 1 plus 2. Well, this just becomes negative 4 plus 2, which is negative 2. So at 1, we're at negative 2. And you can continue the pattern if you want, but like I said, those three should be good enough. And so we'll just kind of come and there we go. And then my range this time, when I look at this, my range goes from the bottom, so negative infinity, up to positive 2. There we go. Okay, looking at I, let's see, kind of similar to what we just did here. Technically, the transformation would be a reflection, and then we're going to shift to the left one because of that plus 1. But we're going to go ahead and build a table. And so once again, I want to pick values where my exponent will be negative 1, 0, and positive 1. So I need to plug in negative 2 to get started. And so let's see, remember that negative in front is kind of like an understood negative 1 that we'll apply in just a moment. So I'm going to get 1/3 raised to negative 2 plus 1 would become a negative 1 power. And that makes me take the reciprocal of that. So I end up with negative 1 times 3, which is negative 3. And oh yeah, let me include my asymptote. The asymptote, since we haven't had this in a while, but my asymptote is going to be at y equals 0 this time because um, I don't have anything other being added or subtracted on the back end. So I basically have an understood plus 0 back here. So y equals 0 is my asymptote. So let's see, that first point was at negative 2 down 3. 1, 2, 3, about right there. Okay. So then let's see, now we're going to plug in a value that will give me 0 as an exponent. So I'm going to plug in negative 1. So I plug in negative 1, so I'll get negative 1 times 1/3. And then negative 1 plus 1 is 0. And 1/3 raised to the power of 0 is 1. Negative 1 times 1 is negative 1. So I have another point right here at negative 1, negative 1. So back 1, down 1 right there. And then last, we'll go ahead and plug in 0. So we're going to get negative 1 times 1/3 raised to the power of 0 plus 1, which would be 1. And so negative 1 times 1/3 is just going to be negative 1/3. So at 0, we're at negative 1/3, about right there. And once again, using those 3 points, we'll just make our smooth curve going to the left like this, and then to the right, we go along the guardrail, and that's fine, just like that. And then our range for this one is from negative infinity up to 0. All right. One that we haven't seen yet is whenever the exponent is negative. And so really nothing really changes. It's still going to be pretty similar to what we've been doing. You just have to be a little careful with your algebra. I will mention that if you are using the MyMathLab platform, this is a reflection across the y-axis. Okay, and first you would shift to the left 2 because of the plus 2, And then there's that reflection across the y-axis. But once again, we're just going to kind of build a table with this, but I just want to make you aware of that. And so pretty much, yeah, again, I just have that plus 0 on the back end. So basically, I'm going to have a horizontal asymptote at y equals 0. That'll kind of keep things somewhat reasonable here. And so then here you have to be careful because what you plug in, the sign's going to change because of the negative with the x. So if I plug in, for example, the first one we'll plug in is 3. When I plug in 3, it's actually going to be a negative 3. And I'll show my work here. So we're going to have 3 to the power of negative 3 plus 2, right? And so then that would give me 3 to the power of negative 1, which then would become 1/3 when you take the reciprocal. So at 3, I'm at 1/3, just about right there. At 3, I'm at 1/3. Okay, now I want to pick a value where my exponent, when I simplify it, will be a 0, right? So I started with making it a negative 1. Now I want to make it to where it will be a 0. So I'd want to plug in positive 2. So if I plug in 2, I'm going to get 3 to the negative 2 plus 2, which then would give me 3 to the power of 0, which then simplifies to a 1. So that's going to be right there. And then my next one I want to plug in is a 1. And so I'll get 3 to the power of negative 1 plus 2, which is 3 to the power of 1, which is just simply 3. So 1, I'm here at 3. And if you want to find some more points, you can, but this should be fine. So we'll go ahead and connect this. Just make a smooth curve going down. Go along the asymptote. Just put some arrows on there and you're fine. Okay, we got one left here and then we're going to look at something else in the next video, but kind of still graphing though. But this is the same idea, except that our base is going to be 1/2. Once again, I have a transformation to the, this time it's going to be to the right 3, but then there's a reflection across the y-axis. So it's going to shift to the right, but then reflect. So the graph will actually end up probably some over here on the left mostly. And so once again, we want to pick values that will make my exponent -1, 0, and +1. So to make it -1, this is kind of interesting. I need to plug in a -2, and I'll show you the algebra on this. So what's going to happen here is you have 1/2 as your base, and then you're going to have -2 minus 3. And so see those double negatives right there will turn into +2 minus 3. And so then we get 1/2 to the -1 power. And then you take the reciprocal of that and it's 2. Take the reciprocal of that and it's 2. So at -2, I'm at 2. Oh yeah, let me move some stuff around real quick. Okay, I gave myself I moved this over a little bit so I can have a little bit more space. And then also I need to include that horizontal asymptote right there at y equals 0. Okay, so I plugged in -2, which then double negative became +2. 2 minus 3 is -1. Now I need to plug in a -3. I need to plug in -3. And so what happens here is the double negative up here will change that to +3 minus 3. So then I get 1/2 to the power of 0, which is going to be a 1. So at -3, I'm right here at 1. Okay. And then now I'm going to go ahead and plug in -4. Okay. So when I plug in -4, it actually is going to turn that -4 to a +4 minus 3. So I get 1/2 to the power of 1, which is, well, just 1/2. So you can see that I'm getting closer and closer to that asymptote. And if you want to find another point right here at -1, you can. But really, I know those 3 points are kind of close, but that's fine. Just kind of draw a smooth curve right here. So we kind of come up from our asymptote and go up like so, something like that. And there we go. And then the range on both of these, because I didn't do the range on the previous one, they're both going to be from 0 to infinity. From 0 up to infinity. Okay, I have a couple more that we need to graph, but I'm going to go ahead and stop the video here and continue another one.